Question 6, we've got a little bit of astronomy stuff. So the Big Bang and the steady state are two theories. So obviously the Big Bang is we've got a small, hot, central explosion start, and then it expanded outwards with the matter becoming more and more dilute over time, but it moving faster and faster away. And then there's the steady state, that's the Big Bang. Lots and lots and lots and lots of stuff, and then it becomes less concentrated, but it's moving away at ever increasing speeds. And then there's the steady state, which is the idea that as space expands, it makes new matter, and that new matter is uniformly distributed as space expands. And we know through redshift that that idea is not correct, and Big Bang is supported more at the moment, depending on what further scientists find. So which line links the evidence? So we need something that links redshift and cosmic background radiation. So if I just put steady state there, both of them have CMB, both, as their theories. Big Bang is the one that uses redshift, steady state does not. So we're after one that says Big Bang. So Big Bang, redshift, no, that's garbage because both are supported Big Bang. Redshift, no, that can't be right. Steady state doesn't take effect of the redshift. Big Bang, yes, that's looking right. And steady, so it's got to be C. Yeah, because steady state doesn't have both redshift and microwave background radiation, so it's got to be C. You'll have to know while to think about that one then. Next one, we've got some hydrogen spectra, and we can see that they've been shifted towards the red on the latter ones. This galaxy is further away and moving at a faster velocity. And then the question is saying, just use this equation. So we've got the lambda G, lambda O, and we've just got to plug these values into there. So that's nice and easy. So lambda G is 6.72 times 10 to the 7, done, minus lambda O, there, all divided by lambda O, and we just got to follow that. When we do that, we end up with 0.0244, and therefore we've shown that it's roughly the same. Okay, next one. Again, we just got a question where we've got to follow the equation that they're given. You'll always have a few equations where you've not been taught them. You just got to apply what they tell you to do. So we've got to work out the recession velocity V, and we're given the speed of light C, so we're given that there. And then we need Z. Well, Z we worked out before, and we can either use their value or our value 0.244, or we can use the 0.025. We'll use the one that we worked out, plug it all in, and we get our recession velocity. We've just got to, the tricky part is look back to the previous question to find the value for that. And there we go. So next part, the wavelength of the spectral line X measured for a more distant galaxy is this. Explain how this provides evidence the universe is expanding. So we've shown, this is just showing that it's been more redshifted, and then we just got to explain what is the evidence from redshift, which we've done quite a lot of times. So the redshift value will be larger, 1 mark, and that's because the recession velocity is increased, so the galaxy is moving away, and then you must include the faster bit. So a larger redshift value, so you're moving away, that's why you're redshifted, but if you're a larger value, you're moving away faster as well. Next part, observations can be made using telescopes on Earth. Why do we have some telescopes that are in satellites? So the basic idea, we put some in space because the atmosphere interferes with what we're trying to do, and then we just got to unpick what are the different ways that the atmosphere interferes. So satellites are above the Earth's atmosphere, that is 1 mark, and then in one of these, so this reduces interference from dust and clouds, or we can measure all wavelengths of light, because our Earth's atmosphere, we know it absorbs some of the UV, it can absorb some microwaves, some infrared, etc. So it just gives us a better suite of wavelengths or frequencies that we can measure the universe with. And that's that.